Hello everyone, this is Puya. In this video, I'm going to talk about another topic called combination. We already discussed permutation. Now, combination is another kind of problem that we don't care about the order of the objects that we're going to select from a group of objects that we are presented with. We just want to know how many different combinations of selected objects we can have. So here in this example, we have 6 different objects, A to F, and we want to select 3 of them. And we don't care about the order. So in this case, A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A, they're all considered as one option, right? We don't care about the order. We want to know like let's say like we have 6 people and we want to choose 3 of them to go, for example, on a selected tour or like a selected project. We want to assign like only 3 of them for a selected project. So in that case, we don't care about the order of the people here, right? We only care about like who's gonna be selected here. So it's a kind of problem that we don't care about the order. We just want to choose, let's say in this example, we want to choose 3 out of 6, right? Here it's going to be, this is the notation for combination. Instead of P, we have C, short for combination. N, in our case, it's 6. We have 6 objects and we want to select 3 of them. So instead of NPR, we have NCR, or C of N and R. So it's R combination of N objects. Okay, so this is going to be somehow related to permutation, right? In order to answer this, right, first we can figure out what is the 3 permutation of 6 objects, right? And then we are gonna eliminate all the 3 permutations of those objects, right? So like you see that like if we wanted to solve this as a permutation problem, we would have 6 times 5 times 4 different ways of doing it. Would be 6 factorial divided by 3 factorial. But in those permutations, we are counting each group of 3 people or 3 objects 3 factorial times, right? So you see that like A, B, C, like A comma B comma C, it's counted 6 times in this permutation problem. A, B, D, it's going to be counted 6 times, 3 factorial times, and so on. So in order to convert this to a combination problem, we just basically have to divide our permutation by all the 3 permutations of the selected objects. So here, looking at this example, right, like here we have 4 places for 6 different objects, right? N is 6, and in this case K is 4. The permutation would be 6 times 5 times 4 times 3, or would be 6 factorial divided by 2 factorial. Okay, but in each of these permutations, each group, let's say A, B, C, D, if object A, B, C, and D are selected, they're counted 4 factorial times. Why? Because one case would be A, B, C, D, another one would be A, B, D, C, and so on. A, C, B, D, A, C, D, B, and so on. Okay, so in order to find the combination problem, we just have to divide our permutation numbers by all the number of ways that we can arrange K items in K spots. Like here, 4 objects in 4 spots. Right? What is the answer to that? That would be 4 factorial in this case. So we basically, to find the combination formula, we just have to divide the permutation expression by all the ways that we can, but the number of ways that we can arrange k items in k spots. That would be k factorial. The permutation of k objects in k spots would be k factorial. The notation for combination, as I mentioned, like one way of showing it is like this, n, c, k. Another notation would be using round brackets, right, parentheses, and like showing it like this. We wanna select k objects out of n objects, right, and would be the permutation divided by k factorial. So an example of that, we have 4 people, and all these 4 people, assuming that we don't have social distancing, assuming that like they can shake hands, we want to see like how many handshakes are we gonna have, right, if each person is gonna shake hand with another one, right? So in that case, if A shakes hand with B, it doesn't matter if it's AB or BA, it's gonna be counted once, right? So for this problem, what we have to do is just basically first find, okay, how many different permutations we can have, right? We have 2 places and 4 objects, right? So it's going to be 4 times 3, or also it can be written as 4 factorial. If I write this like this, p of 4 comma 2, it's going to be equal to 4 times 3, or it's going to be equal to 4 factorial divided by 2 factorial. Okay, but this is gonna give us the 2 permutations of 4 objects. In that case, we are counting each handshake twice. Why? Because once we count A shaking hand with B, and another times B shaking hand with A, right? And it's going to be true for everything else, like for any other pairs, B and C, C and B, C and D, D and C, A and D, D and A, and so on. Okay, so if you want to find C of 4 comma 2, which is also going to be shown like this for C2. Let me make this a little bit nicer. Or it can be also shown as something like this. Can be shown like this. There are different notations for combination. This is going to be equal to p of 4 comma 2 divided by 2 factorial. So in this case, it's going to be equal to 4 factorial divided by 2 factorial times 2 factorial. Okay. So this is 24 divided by 4. It's going to be equal to 6. So in this problem, we're going to have 6 different handshakes. A and B, A and C, A and D. There are 3 of them. B and C, B and D, 2 more. So 5. And C and D. That's it. Right? So 6 different handshakes. So combination is always smaller than permutation because we don't care about the order of the objects. Another example here, like we have a card game using 36 unique cards with 4 suits: diamonds, hearts, clubs, and spades. And cards are numbered from 1 to 9 in each suit. A hand is a collection of 9 cards. So we want to select 9 cards out of these 36 unique cards, which can be sorted however the player chooses. So this statement here, right, shows that we don't care about the order, right, because like they can be ordered any way the player wants to order them. How many 9-card hand suits are possible? So this is basically choosing 9 cards out of 36 cards that we have, right? And it's going to be equal to permutation of 9 permutation of 36 cards divided by 9 factorial. Why? Because like for each of the hands, right, the hands can be sorted in 9 factorial different ways. In combination, we don't care about the order of them. We don't care about the order of that sequence, right? So like we are gonna divide the permutation number by 9 factorial, which is gonna be equal to 36 factorial divided by, for permutation, we would have n factorial divided by n minus k factorial. So this is going to be 27 factorial. And to just basically eliminate all the same cards with different orders, like different ordering of 9 objects, we have to divide it by another 9 factorial. So this is going to be our answer for this problem. 4 more examples. You just got a free ticket for a boat ride and you can bring along 3 friends. Unfortunately, you have 5 friends who want to come along. How many different groups of friends could you take with you, right? So here, you just like have to pick 3 out of 5, right? We don't care about the order. It doesn't matter if Ali or Muhammad or Shian are like who's going to be selected first, who's going to be selected last, right? So we just like want to pick 3 friends out of 5 friends. So this is again a combination problem. So the answer would be like this. Tiffany is packing her bags for her vacation. She has 8 unique shirts, but only 4 fit in her bag. How many different groups of 4 shirts can she take? Again, here, like the order doesn't matter, right? It doesn't matter if she is gonna pick, for example, the red shirt first or the blue shirt first, right? So we just basically, it's a problem of selecting 4 out of 8 objects. So again, this is gonna be a combination, 4 combination of 8 objects, right? Or we can show it like this. Let me make it again nicer. It's gonna be like this: 8 factorial divided by n minus k factorial, which is gonna be 4 factorial, multiplied by k factorial. Again, like it's gonna be 4 factorial. So this is gonna be the answer to this problem. Chris is packing his bags for his vacation. He has, well, this is the same, right? Again, like it's 8 objects, n is 8, but he wants to pick 5 out of these 8. Okay, so that's basically selecting 5 out of 8. Okay, how many combinations can the letters in the strings Mississippi have? Okay, so that's again something that you have to, I want you to think about this one, right? This is like not going to provide the answer for this one because I want you to think about it. Like here, like we have 11 objects, right? And we want to see like how many different combinations of the letters in a string Mississippi we can have, right? So like you have to see like if this is a permutation problem, a combination problem, and how we can solve this. Some other examples are given here, so like please go through them and find the answer. It's very similar to the previous examples. I'm not gonna solve all of them. So basically an R combination of a set A with n distinct objects is simply R element subset of A. So we basically want to select an R element subset of A, and we don't care about the orders of that subset. For example, if we have three different objects A, B, C, and we want to choose two of them, the two combination of the set A can be either A comma B, A comma C, or B comma C. That's it, right? We don't care about the orders in these subsets. Combinations differ from permutation in that order doesn't matter. Okay. So let's say like at VCC you have like 5 different teachers or like 10 different teachers, and you want to specify your 3 disliked teachers, the worst teachers, right, or the best teachers, right? And the order like doesn't matter. So then this is going to be a combination problem of choosing 3 out of 10 teachers that you have. In permutation, like if we want to solve this problem using permutation, we are going to rank one. Like we are going to rank every teacher. So this is going to be the worst, this is going to be the second worst, this is going to be the third worst, right? So if we want to solve this in a way that order matters, if the problem is presented to you to select the worst one, the second worst one, the third worst one, this is going to be permutation problem. If you just like have to select a group of 3, like in the case that order doesn't matter, this becomes a combination problem. As mentioned here, so for in any permutation, we have R factorial different arrangements of R objects that we select. So this is the relationship that we have between permutation and combination. The notation for combination, like it can be shown like this, C of n and r, or like this, or it can also be shown as what I showed earlier, C of n and r. Okay, so this is the formula for combination. You can see that as a result, it's if you want to select R objects out of n objects, it's going to be the same as like you have like the similar number as like choosing n minus R objects out of n objects. Why is that the case? Because like if you select R objects out of n objects, you basically selected n minus R objects that you didn't want, right? So it's the same as like choosing those n minus R objects and not wanting the R objects, right? So C of n and R, the R combination of n object is the same as, excuse me, n minus R combination of n objects. According to the formula, C of n comma 0 is 1. You basically say like in how many different ways we can select no object out of n objects is only one way. In how many ways can we select n object out of n objects is only one way, right? Like selecting everything, right? So that's according to the formula, that's going to be n factorial divided by n factorial, excuse me, and this is going to be 0 factorial, which is 1. So the whole thing is going to be equal to 1. A committee of 5 people is to be chosen from a club that boasts a membership of 10 men and 12 women. How many different ways can the committee be formed if there must be exactly 3 men and 2 women on the committee? I don't know why this is so sexist. Like, let's just like choose 2 men and 3 women. Okay, so if that's the case, these examples are taken from your textbook, so like I didn't design most of them. So here, like if that's the case, we have 2 men, right? So we have to select 2 men out of 10 men, right? So that's gonna be the combination of 2 out of 10. And we also have to select 3 women out of 12 women, right? So this is going to be combination of 3 combination out of 10. So this is like what the answer is. So let me actually again show the actual formula. So for this one, we would have 10 factorial divided by n minus k factorial, which is going to be 8 factorial, times 2 factorial. Okay, and for the number of women's that we have to select, it's going to be, again, it's going to be 12 factorial divided by n minus k factorial, which is going to be 9 factorial, times r factorial, or k factorial, which is 3 factorial. Okay, so this is, if I want to find the actual answer, 10 factorial divided by 8 factorial, that's going to be 90, divided by 2, it's going to be 45, multiplied by 12 factorial divided by 9 factorial, it's going to be 10 times 11 times 12, divided by 6, right? So it's going to be 10 times 11, that's 110, times 2, that's going to be 220, I think. Let me double check. 12 times 11 times 10 divided by 6, that's going to be 6 times 10 times 11. Sorry, 2 times 10 times 11. That's correct. So this is going to be the answer for part, the first part. If this is the case, okay, so this was the based on multiplication principle. You have to select 2 men and 3 women at the same time. But here, look at this one. It's asking you, okay, there must be at least 2 women on the committee. Okay, so this is an example of both addition principle and the multiplication principle. So there must be at least 2 women on the committee. So like in this case, we can have either 2 women, 3 men, 3 women, 2 men, 4 women, 1 man, and 5 women and no man, right? So there are like how many options? 2, 3, 4, 5. 4 different cases, right? And these, they cannot happen at the same time, right? But we have to count all of them. So that's going to be the addition principle. But in each case, we have to, let's say, like if you want to select 2 women out of 12, right, then we have this many options for doing that. And then we also have to select 3 men out of 10 that we have. Okay, so this is the first case where like we have like exactly 2 women and 3 men. But we can also have 3 women and 2 men. We can also have 4 women and only 1 man. And finally, we can have 5 women and no man. So this is going to be 1, but I'm just going to write it as it is. Okay, so this is basically the answer to this problem. This is going to be a combination of both addition principle and multiplication principle. For each case, you're using multiplication principle because in this case you have to choose 2 women and 3 men at the same time, right? But another case as an answer to this problem would be the case that we select 3 women and 2 men, or 4 women and 1 man, or 5 women and no man, right? So like then we have to add all the answers. So the answer for this part, it's going to be this big expression. For part 3, says like there must be at least 2 women and 1 particular man and 1 particular women who are the members of the club refuse to serve on the committee. Okay, so this is gonna limit our options. There must be at least 2 women and 1 particular man and 1 particular woman who are the member of the club refuse to serve on the committee. So this is going to be very similar to the second part, but our n is going to be different, right, for each case, right? So I want you to think about this one and just basically try to modify this so that it would answer the third part, right? So here, like, we have to choose 2 women, but like 1 particular woman doesn't want to be in the committee, so we don't have 12 women serving, right? So like here, like we have to basically select 2 out of 11, and the same thing for the options that we have for men. Okay, there are 10 girls and 15 boys in a junior class and 4 girls and 10 boys in a senior class. A committee of 7 members is to be formed from these 2 classes. Find the number of ways this can be done if the committee must exactly have 4 senior students and exactly 5 boys. Okay, so again, like, I leave it up to you to do this. This is a little bit complicated, right? Because then you have to know that, like, it's not just like 4 girls and 5 boys. Like, you have to have like 5 seniors and 5 boys, right? So like you have to consider different cases where the senior, like the 4 senior might be all like 5 boys, or like 4 seniors might be like different options, like a different combination of boys and girls. So this is like something that I don't want to take the opportunity from you to think about it yourself. Just so like try to do this yourself, and we'll discuss this in the class. And I'm so sorry, like, if these examples are not like very like inclusive or politically correct. As I said, like, most of them are taken from your textbook. Find the number of ways to choose a pair of A and B where A and B are the elements of the set X such that absolute value of A minus B is equal to 5. Right? We already did that early on in the course, but now we can think about it as a combination problem. So like try to like answer that. Like, so this is again a combination of both addition principle and multiplication principle. This was answered in a previous video. In MATLAB, if you want to find the like different R combination of n objects, you can use the function n choose k, right? N and R, like, they can have like any name that you want. They're just basically variables. Okay, so like here, for example, if we say like n choose k v comma 4, where v is a string of like 4 letters, it's only like one way of choosing 4 out of 4. So that's the only combination we can have. If we have to, if our k is 3, then there are only 4 ways of selecting 3 objects out of 4 objects, right? Why is that the case? Because this is going to be like 4 factorial divided by 3 factorial times 1 factorial. Well, let me write it like in order. 1 factorial times 3 factorial. So 4 factorial divided by 3 factorial is 4, right? So like this is like how we have only 4 different ways of selecting 3 objects out of 4 objects. The same thing for when k is 2 or k is 1. So as a summary, permutation, how many different arrangements of k elements of a set of n elements we can have. But so this is what permutation answers. Combination answers how many different unordered arrangements of k elements of an n element set we can have, right? So in the combination, the order doesn't matter. Now, in the next few slides, we're going to talk about very basic probability, right? So we want to answer this question. What is the probability of flipping exactly 2 heads on 3 coins? Okay, so what is the probability of flipping exactly 2 heads on 3 coins? Okay, so if I flip coins, like if I flip 3 coins, or if I flip a coin 3 times, these are the possible outcomes that we can have. We can either have 3 of them head, 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 tail, head, tail, head, head, tail, tail, right? Tail, head, head, tail, head, tail, 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 head, and finally tail, tail, tail. Okay, so these are all the possible outcomes. These are like all the possible outcomes of flipping a coin 3 times or flipping 3 coins, right? So we have 8 different outcomes, right? Why is that the case? Because like for each flip we have 2 options and we're doing it 3 times. So that's basically what we have, 2 raised to power 3. Sorry, 2, not 3. Okay, so we have 8 different outcomes. Out of these eight outcomes, how many of them are desirable for us? We want to say like find the probability of flipping exactly 2 heads on 3 coins. So here, like this is one of the desirable options. This is another one. This is another one. And that's it, right? So the probability, it's the number of desirable outcomes divided by all the possible outcomes that we can have, right? So the answer to this question would be just basically 3 out of 8. 3 out of 8. Okay, so that's basically a very good example to introduce to the concept of probability. Like probability is like to find the probability of an event happening, we have to first figure out how many different possible outcomes we can have, right? And out of those outcomes, how many of them are desirable? Like in this case, like how many of them would have exactly 2 heads, right? So this is how you would answer this kind of problem. Now, so another example here. We are flipping 4 coins, or flipping a coin 4 times, and it's a fair coin, right? What does it mean? It means that like the chance of getting like having like a tail, or like the head showing up, is exactly the same. So like probability of head and tail are both 50%. What is the probability of having exactly 1 head and 3 tails, right? So this is basically the same as probability of having this sequence, or this sequence, or this sequence, and finally this sequence. Oh, sorry, 17. Okay, so like you can answer it like this, right? right? Probability of this happening, right? Probability of this happening. So we have like exactly 4 coins and we're flipping them. So the number of possible outcomes is 2 times 2 times 2 times 2, or 2 raised to power 4, because for each coin we can have 2 options, right? Like either head or tail. Okay, out of these 16 possible outcomes, how many of them satisfy what we want, having exactly 1 head and the rest of them tails, right? So you see that like either this sequence, this sequence, this sequence, or this sequence, right? So this is gonna be like the answer like would be just 4 out of these 16 outcomes. Only 4 of them would satisfy this like desirable outcome. So the answer for this would be 4 out of 16, or 0.25%. Another way of answering this, right? So if you want to look at the exact formula of probability, right? So the total possible outcomes that we can have, it's going to be 2 raised to power 4, right? And if you want to have exactly 1 head out of these 4 flips, right? So this is basically choosing one of these places out of these places, just choosing like one of them for like as a place for head, and the rest of them has to be tail. So the problem would be just like selecting or choosing or 1 out of 4, right? So we basically have to select 1 out of 4. Okay, so this is the answer to this one. Now if we want to make this a little bit complicated, what is the probability of having exactly 2 heads, right? So again, right, one way of doing it is just like counting how many desirable options that we have, but it's gonna get a little bit more complicated if I want to like find all the sequences, right? So to answer this one, it's gonna be easier if we use this formula that we found again. So what are the total possible outcomes that we can have? It's 2 raised to power 4, right? That's like how many different sequences of head and tail we can have when you flip a coin 4 times, or flipping 4 coins, right? Now here we want to choose 2 of these. We want to select 2 of these, and we want to place head in them, right? And the rest has to be tail. So it's basically selecting 2 out of 4. It's going to be a 2 combination of 4 objects. Why is this a combination problem and a permutation problem? Like not a permutation problem, because here, like this one, if you have something like this, right, you just like these 2 are gonna be the same, right? It doesn't matter like if like it's not head A and head B, like the order doesn't matter, right? So like we basically have to choose 2 places out of 4 places to place the heads in them, and then the rest has to be tail. Okay, so this is a combination problem. And what's gonna happen if we have 10 flips, right? To answer this one, again, this is gonna be very similar to this. Instead of 4, we're gonna have 10. Okay, so that's basically how you can answer this problem. You just like select two of these positions and like you place the heads, how many different ways you can select 2 out of 4? This is it. And how many total possible outcomes we can have? Like it's 2 raised to power 10. Now, so this is another example. Let's say that you're playing basketball. The chance of hitting the basket is 80% each time. Like you say, like you're a very professional player or like semi-professional player. Out of like basically statistically, like your chance of having a successful throw would be 80%. Okay, what's the chance of having exactly this sequence? Exactly this sequence. So basket, 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 miss, miss. Right? What is the chance of having exactly? What is the probability of having exactly this miss? This sequence, right? So if your chance of hitting the basket is 80%, what is the chance of missing, right? If the chance of basket is, the probability of basket is 0.8, what is the probability of missing? It's going to be 1 minus 0.8, right? It's going to be 0.2 or 20%, right? So this becomes a multiplication principle problem. What is the probability of hitting the basket in the first time? 0.8. What's the probability of the second one? 0.8 times 0.8 times 0.2 times 0.2. What is the probability of having this sequence? Exactly this sequence. Again, it's going to be 0.2 times 0.8 times 0.2 times 0.8 times 0.2. Now, this becomes a little bit, now like the next question becomes a little bit problematic, right? Like it's like a little bit more complicated, not problematic. So it's a little bit more complicated. Okay, so here it's asking you what is the probability of hitting exactly 3 baskets, right? Exactly 3, right? So one way of doing it is just like basically counting like how many different sequences we can have with 3 baskets and 2 misses and add them up, right? So like this would be one of them, this would be another one, for example, and there's so many of them, right? There's so many of them, right? So like this would be another one, let's say like BB, M, B, M, right? And like we have to do that, right? So how can we do this, right? So like, so we say that we want to have exactly 3 successful throws, right? So probability, like, so like how many different ways we can select 3 out of 5 throws and place B in them, right? Place successful throw. That's going to be a combination problem. So we have 5 throws. We want 3 of them to be successful. Okay. Now, so we do that, right? That's done, right? But for each of them, right? So like now, like we selected 3 places for basket, 2 places for miss. What is the probability of hitting the basket, having a successful throw? It's 80%, right? So that's going to be 0.8 times. So like let me answer, let me clarify this. For each of these probability, for each of these sequences, what is the probability of this sequence happening? 0.8 times 0.8 times 0.8 times 0.2 times 0.2, right? It's the same for this one. It's the same for this one. It's the same for other sequences with exactly 3 baskets and 2 misses. How many of these sequences can we have with exactly 3 baskets and 2 misses? This many, right? So the answer to this question would be equal to C of 5 out of 3. Let me again use the equation here. So it's going to be 5 factorial divided by 2 factorial times 3 factorial, right? That's this combination, like how many sequences we can have it exactly 3 baskets and 2 misses. For each of these sequences, what's the probability of it happening? It's going to be 0.0 point. Let me go to the equation. It's going to be 0.8 raised to power 3 times 0.2 raised to power 2. Okay, so that's the answer to this question. What is the probability of having exactly 3 successful throws out of 5? Now, again, let's make it a little bit more complicated. What is the probability of having at least 3 out of 5 successful throws, right? So this, again, it's a combination of addition principle and multiplication principle. Here we had the multiplication principle, but here, you say, at least 3 out of 5. So this is going to be equal to having probability of 3 out of 5 3 successful out of 5 plus probability of 4 successful throws out of 5 plus probability of having 5 out of 5. Okay, let me make this a little bit smaller. Okay, now for each of them we can calculate them the way we answered the previous part. What is the probability of having exactly 3 successful throws out of 5? We already calculated it, right? This is what we have. Now, what is the probability of having exactly 4 successful throws out of 5? Right? So first, we have to select which of these 5 throws we want to be successful, how many different sequences with 4 successful throws and 1 miss we can have. That's basically selecting 4 places out of these 5, right? And it's a combination problem. So if I do it, it's going to be 5 factorial, 4 factorial, 1 factorial, 0.8 raised to power 4, and 0.2 raised to power 1. And finally, the last one, it's having exactly 5 successful throws out of 5. So this one, it's going to be basically we want all of these to be basket. We want all of them to be B. How many sequences we can have out of 5 that all of them are B? Only one, right? Only one sequence, which is the combination, 5 combination of 5 objects. So it's going to be 5 factorial divided by 5 factorial times 0 factorial, which is going to be 1, exactly 1, times 0 times, let me copy and paste this here. So comes 0.8 raised to power 5 times 0.2 raised to power 0. We can ignore this one, but this is to be complete, I wanted to show you this. So that's the probability of this event happening, right? You see that this is a combination of addition principle and the multiplication principle. For each case, we have the multiplication, but to add the probability of all these options, we have to add the probability of each one. This example that we just did, it's the it's a general example of Bernoulli trial. In the theory of probability, a Bernoulli trial or binomial trial is a random experiment with exactly two possible outcomes. So here it was basket or miss, or fail or pass, right? Success and fail, or generally A or B, where A and B are mutually exclusive. It means that they cannot happen at the same time. We can't hit the basket and miss at the same time, right? So they're mutually exclusive. The probability of success is the same every time the experiment is conducted, right? So like here, like we assume that the like a probability of having a successful throw, like every time it's going to be 80%. It's not going to change. It's fixed. So the mathematical formulation for the Bernoulli trial is known as the Bernoulli process. So some of the examples here, like so it can be like flipping coin, like just like seeing like if like out of like n different childbirth, like how many girls or how many boys we can have, like the success rate or the pass rate for like a specific course. So like there are different examples of this Bernoulli trial. Let's look at this one. So for a single Bernoulli trial, given the probability of event A to be P, the probability of event B is 1 minus P, right? So that's what we had here. The probability of hitting the basket was 80%. The probability of missing was 20%. Or the probability of, if the probability of having the head would be 50%, the probability of the tail would be, for a fair coin, would be 1 minus 0.5, again 50%. So for n statistically independent Bernoulli trials, let's say, like as an example, n tosses of the coin, for example, or n unrelated exams, right? Like each toss or each exam would be independent from the others. The probability of exactly k success events in n experiments with the single probability p is given by this one. So we basically have to choose out of these n experiments, out of these n coin toss, or like n exams or n independent events, like how many ways we can select 4 of them to be specific to event A, right? So like we have to choose k out of n, choose k, right? And for each of these events, right, we want event A to happen k times and event B to happen n minus k times. What is the probability of event A happening? It's P. What is the probability of event B is happening is 1 minus P, or let's say Q. Okay, so then event A is to happen k times. It's going to be P raised to power k. The event B, it's going to happen at the probability Q and n minus k times, so it's going to be Q raised to power n minus k, where Q is 1 minus P. This is exactly what we had here. Look at it. This is n choose k, so we're choosing like in how many different ways out of 5 we can have 3 basket and 2 misses, right? So this is n choose k, right? This is P. This is the probability of event A, which is hitting the basket, right? And we want it to happen exactly 3 times. And what is the probability of missing, which is going to be 1 minus 0.8. And we want this to happen only 2 times, right? So this is what the Bernoulli formula is. You can calculate it using MATLAB, using n choose k function, right? And just like implement a p raised to power k and 1 minus p raised to power n minus k. So as an example, the probability of failing an exam is 1%. What is the probability of failing 3 exams out of 30? Right? Let's say like all the exams have the same pass rate. Right? Let's say like you have to have like during your studies you have to take 30 exams. And the probability of passing an exam is 99%. The probability of failing is only 1%. What is the probability of failing 3 exams out of 30? Right? Exactly 3 exams out of 30. Right? So it's going to be n choose k, where k is 3, n is 30. In this case, probability of failing is 0.01. Right? It's given here. And it's the same for each exam, right? So this is like not a very realistic problem. So if that's the fail rate, the pass rate would be 0.99%, right? So then if you do that, the probability of this happening would be only 0.3%. 0.3%. It's going to be very small, okay? Another example, we have 5 people at the bus stop and you have 8 snowballs. You're pretty good at throwing, and with a 60% accuracy on a single throw. What is the probability of getting 5 hits out of your 8 snowballs? Right? So like here, like n is 8, and we want to have 5. We want to calculate the probability of having exactly 5 successful throws, right, out of the 8 snowballs, right? So like we want to basically like see like how many sequences like this we can have: success, 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 fail, 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 right? We have 8 throws, and we want to see like in the sequence of 8 success and fails, how many sequences like this we can have so that 5 of them are successful, 3 of them is fail, right? We can't just like it's gonna take us a long time to like count them like this, right? So this is gonna be another one, for example, right? But if I want to do it like this, like if you want to find all these sequences, it's going to take me a long time. But using the combination problem, we know that like we basically like have to figure out like out of these 8 places, we want to select 5 of them. We want to choose 5 of them to be success, and the rest of them has to be fail. So that's going to be choosing 5 out of 8. And for each of these events, right, the probability of success, it's going to be 60%. The probability of failing, it's going to be 0.4%. So this is going to be, let me write it here. And let me use the formula equation here. So this is going to be, we have n is 8 factorial divided by n minus k factorial, which is 3 factorial, times 5 factorial, right, multiplied by, right, so like the probability of this one to be successful like is 60%. This one is 60%, 60%, 60%. So it's going to be 0.6 raised to power 5, and then this is going to be probability of failing, it's going to be 0. Or missing 0.4, and it has to happen 3 times, right? So it's going to be raised to power 3. Okay, so this is the answer to this, and like if you calculate it using MATLAB, it's going to be 0.27. So 27% or 28%, the probability of getting 5 hits out of your 8 snowballs. On question for you, what is the probability that in 5 rows of a fair die, a number 1 appears twice? Right, this is like a fair die, so it means that like each number would have the probability of 1/6, right? So the number of trials is 5, exact number of success is 2, what is the answer? So again, this is going to be choosing 2 out of 5. Choosing 2 out of 5. 1 over 6 is about 0.6, 0.16, right? So there are these many sequences, like where we have, let's say 1 and 1, and then some other numbers, right? Not 1, right? So like 1, 1, not 1, not 1, not 1, right? Again, like one of the other sequences would be 1, not 1, not. And like we want to see like how many different sequence like this we have, right? This many, right? Basically we have to select or choose 2 out of these 5 and place 1 in them. So that's going to be 2 out of 5, and choose K, 5, choose 2. And for each of these sequences, excuse me, the probability of 1, it's going to be 0.16 or 1 over 6, and it has to happen twice, so that's why I raised to power 2. And then the probability of not having a 1, it's going to be 0.84. It's 1 minus this, right? And it has to happen 3 times, so that's why this becomes the answer. Okay. So this is like a very similar problem to what we did before, right? So I don't want to solve this one for you because you can do it yourself now, right? So it just basically like you're throwing a coin 8 times. What's the probability of having exactly 3 heads in the sequence? Okay. So you can just like basically solve this yourself. Similar to this, like again, like we are like 5 flips, and like what is the probability of having exactly 3 heads in the sequence? A club of 9 people wants to choose a board or a committee of 3 officers, president, vice president, and secretary. Assuming the officers are chosen at random, what is the probability that the officers are Marsh for president, Sabita for vice president, and Robert for secretary? Okay, so again, so this is like a probability problem, right? How many different options do we have to choose 3 people for these roles, right? So for president, we have 9 options, right? For vice president, we have 8 options. For secretary, we have 7 options, right? So these are how many different ways we can select. This is like the total possible outcomes, number of total possible outcomes. Okay, so this is what it is, right? 9 times 8 times 7, or it's gonna be like, if I write it in terms of permutation, is 3 permutation of 9. Why is this a permutation problem, not a combination problem? Because it matters who's gonna be president, who's gonna be vice president, who's gonna be secretary, right? If they didn't have any ranking, then it would become a combination problem. But because they have ranking, it becomes a permutation problem. So out of these total possible outcomes, right, how many desirable options we have? Only one, right? Where like Marsh is going to be president, Sabita vice president, and Robert secretary. So what is the probability of this happening? It's going to be 1 over this. Okay, these are the total possible outcomes we have. How many of them are desirable? Only 1 of them. A card game using 36 unique cards, 4 suits. cards numbered from 1 to 9 in each suit. A hand is a collection of 9 cards which can be sorted however the player wants to choose. So like it means like this is gonna become a combination problem. What is the probability of getting all 4 of the ones in your hand? What is the probability of getting all 4 of the ones in your hand? Okay, so first of all, let's look at the general formula for the probability, right? So first we have to find the total number of hands that we can have. The total number of hands we can have. Okay, we already did this, right? This is basically selecting why is this, sorry, this is basically choosing, we have 36 unique cards and we want to choose 9 of them, right? So it's going to be 36 choose 9, or 9 combination of 36 cards. These are the total number of hands we can have. Okay, in how many of these hands we have all the ones in the hand, right? So that's like we basically have to find the number of desirable options that we have, right? So in this case, like let's assume that like we place all the ones aside, right? And we want to choose the other 5 cards that we have to have to form a hand, right? So if we place all the ones aside, then out of the 36 cards that we have, we would have 32 left. We have 32 left, right? So so this is going to be basically, now we have to choose 5 out of these 32 cards, right? And then add the 4 ones into the hand to make 9 cards. So this is like the number of ways in which this event can happen, right? Where you pick 5 cards out of the other 32 cards, which doesn't include the ones, and then add the 4 ones into the hand, right? So number of hands with only 4 ones, it's going to be this many. You can think about it. I'm providing you the answer, but like I know that like you have to think about it. The total number of hands, it's going to be this many. Let me just write it here. C of 36, 9. Okay. And the answer is going to be this one divided by this one. To win a particular lottery game, a player chooses 4 numbers from 1 to 60. Each number can only be chosen once. Each number can only be chosen once. If all 4 numbers match the winning numbers, regardless of their order, the player wins. What's the probability that the winning numbers are 3, 15, 46, and 49? Okay, so in like, what is the total number of total possible outcomes that we can have? We want to select 4 cards or 4 numbers out of 60, right? So it's basically C of 60, 4. Okay, and the order doesn't matter here, right? So it said like regardless of the order. If all 4 numbers match the winning numbers, you win, right? what is the desirable number of outcomes? The desirable number of outcomes is only one, right? It's just like when the numbers that we choose are exactly these four: 3, 15, 46, and 49. So the probability of winning this lottery, it's going to be 1 over 60 for 60 choose 4, or 4 combination of 60, right? Because only 4 specific numbers are going to be the winning hand, right? What's the probability of having exactly these numbers, right? It's going to be 1 over 60 choose 4, right? So if I write it down, it's going to be 56 factorial divided by 4 factorial, sorry, multiplied by 4 factorial divided by 60 factorial, which is like basically 1 over this number. Okay, see, it's going to be a very small number because it's 56 factorial divided by 60 factorial is going to be 60 times 59 times 58 times 57. All of that is in the denominator. On the numerator we have 24, so it's going to be very small. So like you can like solve exactly the same problem, but think about it that this time, if the order matters, what's the probability of winning? This is like usually the case in lottery, right? The order matters. Right here, like it says, like the order didn't matter, but like here the order matters. If you try to do that, let's assume that we have 56 different balls from one pack and another 46 from one hand. Like you pick 5 out of this one and 1 out of this one, and you should get exactly the correct sequence, right? So what is the probability of hitting the jackpot, right? This time, if the order matters, this becomes a permutation problem, right? So if I do this here, so for the first number we have 56 different options, for the second one 55, for the third one 54, for the last for the fourth one 53, and for the last one 52, and for the one from the other pack we have 46 different options. So these are the total number of possible outcomes. The total number of possible outcomes. What is the probability of hitting the jackpot, right? The winning sequence is going to be only 1 out of these many, right? So the probability of hitting the jackpot is going to be 1 over this number. Okay, it's going to be like, it's a very small number. Okay, just like as a general knowledge, the chance of getting hit by a lightning, it's 1 over 100,000, or let's say 1 over 10,000. The probability of getting hit by lightning is 1 over 10,000. The probability of hitting the jackpot is less than probability of getting hit by lightning twice, right? So in your lifetime, like if you have such a jackpot. So this again, like a summary of the Bernoulli trial. So like if you want to say like exactly k heads in n flips of the fair coin, right? Then this is a typical Bernoulli problem. So it would be, the answer to this would be let me write it like this: C of n comma k multiplied by probability of having the probability of, let me write it like this: P of h raised to power k. So like I write it like this: probability of raised to power k multiplied by probability of the tail raised to power, I'm sorry, n minus k. I'm just gonna, okay, if it's a fair coin, these numbers are going to be 0.5. So this is going to be C of okay, and this is going to be 0.5, and this is going to be 0.5 as well. That should be n minus k. Okay, and then also, like, you see that this would be simplified. It's just going to be C of nk. If the P of A and P of B are the same, right, this becomes basically 0.5 raised to power n. Right, which is like consistent with the definition of probability. These are like the like this is going to be 1 over the total number of outcomes, and these are like the number of desirable outcomes. So this is the number of desirable outcomes divided by the total number of outcomes. A little bit about statistics. So just like if you have n different numbers, the mean or the average can be calculated like this, right? The arithmetic average. There are other kinds of averages. So the arithmetic average is going to be calculated by a summation of all n numbers divided by the number of numbers that we have, the total numbers that we have. The variance is a measure of the variability of the data. So like we want to see like how the data is distributed, right? The variability of the data. All of them are like if you're given an average for like n numbers, right? Like all of those numbers can be the same as the average, or like they can be far from the average, but like some of them can be very far from the average, some of them like far from the other side, and then like getting the same average. So the variance is basically a measure of the variability of the data. We want to see like how much they differ from their average, right? So this is the formula for the variance. And another term in statistics that uses the standard deviation is basically the square root of the variance, right? The square root of the variance is the standard deviation. In MATLAB, you can find the average using the mean function. You can find the variance using the var function. So like here, like you're given a problem, you're asked to find the average and the variance. You can also use the STD. That's not a good abbreviation, but the standard deviation can be found using this function. You can also find the min and max of the data. You can find the median. Median is basically, I think it would be explained better like if I use an example. Like here, like let's say like I have 1, 10, 5, 4, 3, and 6, and let's say 9. Okay, so if I want to find the average, I'm going to add all these numbers up and divide it by 7, right? The median would be the number that would be exactly in the middle in the sorted sequence, right? So let me just like sort these numbers. It would be 1, 3, 4, 5, 6, 9, and 10. Did I miss something? No, right? So in the sorted sequence, 5 is in the middle. So that's the median of the sequence, right? So that's the difference between the average and the median. Okay, so these are the videos, textbooks, and slides that I used for these slides. Again, like, I'm sorry that if some of the examples were not inclusive or politically correct. I try to modify it for future offerings of this course. Thank you so much. Stay tuned for future videos.